Hello, my name is CECILIA Valdes, and today I'll be presenting Lab 3, Magnetic Field of a Bar Magnet. The purpose of the lab was to better understand the relationship between distance and the magnetic fields and to use different fundamental concepts to find the magnetic moment of a bar magnet. Some of the fundamental concepts that this laboratory practice implies are mainly two, the Biot-Savart law and the distance dependence equation of a magnetic field. The Biot-Savart law describes the magnetic field produced by a current carrying wire, and it states that the magnetic field at a given point is proportional to the current flowing through the wire and the distance between the point and the wire. The distance dependence equation for a magnetic field is given by the inverse square law, and what this means is that the strength of the magnetic field will decrease with the square of the distance from the source of the field. And well, the results of this lab in general, just to recap, is that n was equal to negative 2.3746 meters and that the magnetic dipole equaled 5.78 amperes per meter square. For this lab, we collected our data using a magnometer on a smartphone. And well, here the data on the left shows the magnetic field on axis, and the one here on the bottom is for B-perp. And as you can see, they each provide an average of our magnetic field on each of the locations tested. And we have here on the right hand the values of the average distance and average magnetic field. It's only for the on-axis values that were linearized and then plotted. And here pay close attention to our equation because these values will be used later in the lab. Well, just to point out some observations during data retrieval, first of all, the magnometer moved closer to the magnet. When that happened, the x component of the magnetic field increased, and when it was further away, the magnet measured almost a zero magnetic field in the x direction, so that's like important to note. And also, it is important to note that the B Earth value had to be subtracted from the measured Y values in order to compensate for the magnetic north property. Now on to calculations. Well, we apply the Biot-Savart law in order to calculate the magnetic dipole moment. As you can see here is the equation in its two different forms, but it equals each other. And first we solve for our K by plugging it in our ln in our E to the negative 13.67, which is one of the values that we got from our y-axis in our data that I showed you before. And we know that from the distance-dependent equation that Bx is equal to this value. And using the value of r is equal to 1 meter, we can solve for k, which is 1.56 times 10 to the negative 6. And then we set this relation and we plug all of our known values and solve for mu, and this value ends up being 5.7853 amperes times meter squared. Well, now we're gonna go over our glow script code. This code includes a function for magnetic field, which yields a magnetic field at a particular location in the presence of a dipole. And well, also we have four observation locations, two per and two on-axis locations. This is very important because the code calculates also the magnetic fields corresponding to each of them. And well, to get the magnetic field and the magnitude and the observation location at 45 degrees with our axis as a reference, a perpendicular value had to be inputted into the dipole function. Our computational model we have gives us a visual information for our function, and it shows a purple arrow that corresponds to the magnetic field on axis, a blue arrow that corresponds to the perpendicular magnetic field, and a green arrow that shows the magnetic field at a 45-degree angle. And well, from this picture, we are only able to see three blue arrows, but our data actually tells us that we have four blue arrows. And well, since all of these perpendicular arrows have the same magnitude and are equal in direction also, the blue arrow in the middle is on top of the arrow that's missing. To wrap up this lab, I'm going to be answering some questions. And well, if we had a meter stick laid in some unknown angle in respect to the Earth's magnetic field, we would have a more complex calculations as we could not have assumed that our x started at 0. And well, since in our case, by taking into account our magnetic north, we were able to make everything more convenient and make sure that the x started at x component began at 0. And for the other questions, if we added another magnet identical to the first and placed the two end to end, the value would have of the magnetic field would be more, the magnitude would be greater. However, it would have not been completely doubled. Well, this is all for today. Here are the results, and thank you for watching.